Hi guys, so today we're going to be doing some exercises with the multiple regression in Excel, and we're also going to be seeing it in Minitab, okay? So these are the exercises we did in class, and we have a company who wants to forecast income based on how much we invest in advertising, our campaign days, our prints, and our posts. And this is very important because even though you can see that there is a period here, it is not considering the period, okay? It is not linear. It is multiple regression, okay? Why is it multiple? Because we have several different variables, okay? So one of our first things that we have to define what is it that we're trying to forecast. So here, like I said at the beginning, we are trying to forecast how much income we will receive when we consider how much we invest, how many days we have a campaign, the print, and the post. And there's several ways. You can do it in Minitab. You can do it also by hand. You can do it by using the data analysis, okay? So one of the first steps that we need to do is we need to observe the Y, and this is the Y, okay? Income is Y. And we need to select those variables that have the greatest influence, okay? So technically, we could do the whole thing and consider all of our variables, and we're going to do that. That's going to do the first thing. And then we'll try to figure out if there are certain variables that influence my model a lot more, okay? So the very simple part, we're going to go to our data, analysis tools, and there is one that says regression, okay? It says regression. And the first things it asks is your Y. So there's my Y. And then it asks for all my X's. These are all my X's. These are all my variables, okay? And the next thing is, since we do have a header, we need to put that we have a header. And our confidence level, statistically 95% is actually the norm, okay? Unless the problem guides you and tells you, okay? And the next thing we're going to do is we're going to go ahead and just give it a range where it will give me my answer. And with that, we have our answer. So the very first things that we have here, and these are important for me to determine, are my errors, okay? And we've been talking a lot about errors in the last class, but here we are going to talk about these types of errors. The first one is my R. This is my regular R, and it indicates the strength and direction of the relationship between my variables, between my different variables, okay? So it's positive, which indicates that basically it's increasing. That means every time I increase something, my income will increase. So that means if I increase my advertisement, that's going to, it should increase, okay? But it's the overall, not necessarily one, but the overall. That means if in general, I'm following this model, it goes in a trend that goes upward, okay? And if you remember when we talked about R square, it indicates the percentage of, it's in a percentage, the relationship between my variables. And remember that if it tends to be higher than 75%, it's a pretty good model. Why? Because they have a strong relationship, okay? And then we have this. This is our error that we've talked about in the last classes. And this is my adjusted error. My adjusted error is going to tell me, basically, my R square adjusted to this error. And it went down a little bit. There are some models where it won't go down. It can happen. But here the error brings it down a little bit. This relationship, which is pretty good because it's still 75, so we can keep it. We'll say it's a good model. And if you see here, right here, this right here is going to be our equation. So my intercept is my A, and each of these is going to be my answer, okay? These negative means that it goes in the opposite direction, okay? So if I reduce my investment in advertising. That means it's not going to affect, it's not going to go down, it should go up, okay? So our equation would be y is equal to this particular number, which is 13.90, okay, 91. And this is it's supposed to be plus, but since we have a negative, we'll go negative 1.2279. And this is investment plus 1.2279. And this is going to be campaign days times my campaign days plus, and it's negative, so it's minus 0.008871 times prints plus 0.3419. You can decide how many different, or when you're doing it informally, you can equal it to what you see in the cells times posts. Okay, so this is my formula, and this formula is where once I get my information, so they can tell me, hey, what's going to happen to my income if I invest, let's say, 60 advertising, okay? If I invest 60 advertising for 100 days, I only do 1,000 prints, but I make 500 posts, how much would that be? And so I would just insert it in my formula and I would get my answer. But we have to consider that sometimes some of our variables obviously have more correlation or have a lot more influence on our models. So what we're going to do is we're going to use our correlation tool, okay? So we have here the data analysis, and there is one that says correlation. Okay, so we'll go ahead and it asks me for all of my data. I have this, and it's going to ask me right here to put it. So I have my data, including my y, x's and y's. I do have a header, and I'll just say that it's right there. Okay, I'm going to go ahead and take some of these, just so we don't have that many decimals. Okay, it's a little bit easier to read. So step one when we're doing this, and this is trying to predict our income from the investment in advertising, the day in campaign, the number of prints, okay? Using this correlation to try to see which one has the biggest influence. So what we're going to do is observe variable y. This is variable y right here, okay? And select those variables with the highest influence on it. How do I know? They have to be greater than 0.75. And so greater than 0.75 are these three, okay? These are greater. Step two is now we're going to select our x variables, and we're going to observe the different relationships that we have between our variables x, okay? If they have a correlation greater than 0.75, they should not enter into the same equation. Why? Because we are literally kind of clashing them together, and so they lose value. So the idea is to keep one. It would be to keep one for the model and not the others. So if I look at this, these right here are 0.75. This is 0.75, and so is this greater than, and basically that's it, okay? So the prints we're not going to use because they don't have it. Here in the investment, we would use investment and the post. Why investment and post? Because investment and post is going to be where we already know that investment has a high correlation, which is 1, and the post doesn't have that high correlation, which is going to actually help my model, or should help my model. And different systems are also going to give you different answers, and this is where you have to analyze it and define which one you want, okay? And the next, which one else am I going to use? Well, this one. Why? Because this one right here is this one. I'm eliminating these two and I'm going to keep campaign days. Okay. And this one I won't use because this one is right here. I won't use specifically because I don't have that big of a correlation with the income. Okay. So what will we do next? Let's run our system again, and we'll run it first for campaign days, because the only disadvantage is that let's go to regression, and our Y stays the same, but our X is our campaign days. Okay. And so put it down here. And here we have, it's fairly high, if you can tell. We have a fairly high, not so high, like it went down. Remember, we had 0.75 adjusted. Now adjusted, we have 0.67. So it kind of went down. It does affect, but it's probably might not be the best. What would our function be? Well, it would be income is equal to 14.8955 plus 0.8924 times how many campaign days I'm having. Okay, it's not bad. We can work with that. Okay, but let's see how we can have it, but using our other that we had chosen, which is going to be our advertising and it's going to be our advertising, and if I'm not, it was our post, right? So here we go. We're going to do the same thing. Regression, that stays the same. And investment. Oh, and they said they have to be together. So let's go ahead and I'm gonna, for right now, eliminate this one and eliminate this one, okay? Just so we can see our problem. And here we go. Okay, there we go. And we'll change this one since we eliminated. I'm sorry. We go ahead and we come down here, kind of moved around, but look at the difference. Here we had an adjusted R square of 0.67, and here we have an adjusted R square of 0.73. So if you look at our errors, our R, which is going to be our direction, okay, how strong our variables are, this one, R square, compared to the first model, which was only using campaign days, is 0.68, and here it is 0.75. Okay, we have an error of 78, and our adjusted is 0.73. So if we look at both models, we could assume, and this is a good point, we could assume that this is actually a better model. Okay, why? Because our R adjusted with the error is much higher than the other. But what happens now if we try to use it with Minitab? Okay, we're going to open Minitab, and in the next video, we'll work on this one.